Now I would like to mention some more information about these parametric formats. And the first thing that I would like to discuss is about extracting out a relationship in between x and y when they have given the things in a parametric format. Now what I mean by that is, now in the previous video we saw that a parametric relationship is something where the x and y behaves according to a third variable. And also I mentioned that in the when we are doing our fundamental studies, at the beginning we described the relationships straight through these equations containing x and y only. And then here in this subject of parametric equations we introduced a third variable, and now we try to see whether it is possible to come up with a relationship in between x and y. I mean, we are trying to see whether we can express y as a variable of x or x as a variable of y without using this third variable. Now this method is not possible for all the parametric equations, but for simpler versions like this we can extract out a certain relationship between x and y. So for example, if we take this one, then what we can do is we can write, we have x equals t squared minus 2t, and we know that from this second equation we can subject t from here. So if we subject t, then it will be y minus 1. So that means instead of t we can use y minus 1. That's what we are going to substitute in this first equation. So then just see what will happen. Then instead of t we substitute y minus 1, so this becomes y minus 2, y minus squared, y minus 1 squared, and this becomes y minus 1. Now you can see that our whole set of equations was converted to a relationship between x and y. So this was the usual format that we were used to have, right? So now this sort of x, now we can even simplify it a little further, and you can obtain y squared minus 4y plus 3. So simply what we have is this relationship, right? So if you plot the curve of this one, you will still obtain this relationship or this plot, right? But the thing is, this sort of extraction is not always possible. So anyway, just keep in mind that there are some situations where we can extract out a direct relationship between x and y, and we can just eliminate the third variable by doing some mathematical calculations. And that's the first point that I wanted to mention. And the second thing is, when we draw a parametric curve like this, right? Now once again we are back into this parametric formats, that is expressing x and y with respect to a third variable, right? So let's say we have drawn the graph like this. Okay, so in this graph we can see that this is the point corresponds to t equals -2, and this is for -1, this is for 0, 1, 2, 3, 4 likewise. Okay, so that means when the value of t increases, the value of t, okay, I am not referring to a x or y coordinate, okay, I am referring to the value of t. So if the value of t increases, then we can see that the graph takes this direction. So we have like there's a certain convention to mark that direction with a arrowhead. So what the meaning of this arrow is that it represents the increasing direction of the variable t. So that means what it gives an idea about these x and y coordinates, or the position of x and y coordinates when t increases, right? So if you are given with a certain parametric curve like this, and if they have mentioned an arrow in this direction, then the data that we can extract out from this arrowhead is that when t increases, the curve will move in this direction but not the other way, right? Okay, so that's the second point that I want to mention. The first one is about extracting out the direct relationship between x and y, and the second point is the meaning of this arrowhead in the curve. And the third point is about restricting the values of t. So that means now we saw that here in this graph we started t from -4, right? And we started t from -2 and we went up to t equals 4, right? But we could have done it at t equals -3, and we could have run this simulation up to a number like this, right? So we have the authority to restrict the t in whatever the way we prefer, right? So let's say if we start t at 0 and if we end the t at 4, then according to this starting point and the end point, we will be starting our graph at this position and we will end the graph in here. So ultimately we will have a curve like this, right? So this will be the starting point and this will be the end point. And remember, we draw an arrowhead in the increasing direction of t, of the time, right? So this will be the starting point, which is t equals 0, and this is the end point. But here the starting point was t equals -2 and the end point was the same. So in this case we can represent the value of t as this one, and here we can represent the value of t with this inequality, right? T is greater than or equal to 2 and t is less than 4. So, and now there are two more definitions that we use. The point that we start is called the initial point, and this stopping point is called the terminal point. So if we write down everything in a general format, then now let's say that our relationships between x and y, for this specific example it was given like this. So basically what we do is we represent x as a function of t and y also as another function of t. So if this is the parametric format, and if t runs from in between 2 points, let's name it as a and b. So in this case a was -2, b was 4, and in this case a was equal to 0 and b was equal to 4, right? So accordingly, the starting point will be, or the initial point will be, the value of x and y when t is equal to a. So the value of x at the starting point will be this one, value of y will be this one, ga, and the terminal point, the value of x will be equal to b, the value of y will be equal to gb, right? Because this is how y behaves when we change the value of t. So this is called the term initial point, or else we can even mention it as a coordinate, right? fa comma ga. So this is the initial point, and this will be the terminal point. Also, I have to say something more about this variable t. Now, as I explained before, normally in most of those experiments we represent the time with the variable name t. So usually we will be starting the time at 0, right? It's obvious, kind of intuitive, to not to start the time at a negative number, right? So usually we have this starting value for the time variable t. But anyway, when you take this parametric equation theory in general, t need not to be the time always, right? Okay,